Ever found yourself wondering how electric car batteries work? The world of electric vehicles, or EVs, is indeed fascinating. These silent, speedy machines owe their prowess to a crucial component, the battery. Just like your everyday remote control or smartphone, electric cars rely on batteries. But these are not your ordinary AA batteries. These are high-power, sophisticated energy storage systems that play a pivotal role in the performance and range of electric vehicles. In the realm of EVs, batteries are not just power sources, they are the heart of the vehicle. They store the energy that drives the wheels, powers the lights, runs the air conditioning, and more. And they do it all without a drop of gasoline. In this video, we'll delve deeper into the intriguing world of electric car batteries. We'll explore how they work, the technology behind them, and the advancements that make them an integral part of our clean energy future. So, are you ready? Dive in to unravel the mystery of electric car batteries. Before understanding how they work, know what makes an electric car battery. Diving right in, an electric car battery, much like any other battery, is a device that stores energy for later use. It's composed of three main components: cells, modules, and the battery pack. Let's start with the cells. Think of them as the building blocks of the battery. Each cell houses a positive electrode, known as the cathode, and a negative electrode, the anode. Sandwiched between the two electrodes is the electrolyte, a chemical medium that allows the flow of electrical charge. When the battery is in use, ions move from the anode to the cathode through the electrolyte, and this movement generates an electric current. Next up, we have the modules. Each module is essentially a group of cells. By connecting cells together in a module, we can increase the battery's voltage and capacity. This is a bit like teaming up for a group project. When you pool your resources, you can achieve more. Finally, we arrive at the battery pack. This is the power center of an electric vehicle. It's composed of multiple modules bundled together, along with a battery management system. This system oversees the performance of the battery, ensuring it operates safely and efficiently. It's the boss of the operation, keeping an eye on things like temperature, voltage, and state of charge. Now, why are these components important? Well, the cells determine the battery's energy density. That's how much energy it can store relative to its weight. The modules, on the other hand, affect the battery's voltage and capacity. And the battery pack? That's where the magic happens. It's responsible for powering the electric vehicle and managing the battery's performance. In essence, the battery pack is like the heart of an electric car, pumping energy throughout the vehicle. The cells and modules are the veins and arteries, carrying that energy where it's needed. And the battery management system is the brain, making sure everything runs smoothly. Now that you know the components, let's understand how they work together. Get ready to explore the inner workings of an electric car battery. Let's begin with the heart of the battery, the cell. Each battery consists of multiple cells, which are further divided into three key parts: an anode, a cathode, and an electrolyte. The anode, usually made of graphite, is the negative terminal, while the cathode, often composed of a lithium metal oxide, is the positive terminal. The electrolyte, a chemical medium, facilitates the flow of electric charge between the anode and cathode. Now, let's talk about the role of lithium ions, the tiny workers inside an electric car battery. When the car is in use, these ions move from the anode to the cathode, traveling through the electrolyte. As they move, they leave behind their electrons at the anode. These electrons, eager to rejoin their ionic counterparts, create a flow of electric current through the external circuit, which powers the car. This process is known as discharging. But how does the battery get recharged? Well, it's the reverse process. When you plug in your electric car to charge, you provide an external source of electric power. This power forces the lithium ions to move back from the cathode to the anode. As they move, they draw their electrons back through the external circuit. This movement of ions from the cathode to the anode during charging stores energy in the battery, ready to be used again. It's fascinating to note that this intricate dance of lithium ions moving back and forth between the anode and cathode can occur thousands of times during the battery's lifespan. However, with each cycle, a small number of ions fail to make the return journey, which leads to the gradual degradation of the battery's capacity. That's why, over time, you may notice your electric car doesn't hold a charge as long as it used to. But fear not. Scientists and engineers are continually working on new technologies to improve the lifespan and efficiency of electric car batteries. For example, advancements in the field of solid-state batteries, which replace the liquid electrolyte with a solid one, are promising to deliver longer-lasting and safer electric car batteries in the future. So, the next time you plug in your electric car to charge, take a moment to appreciate the complex ballet of energy that's happening right beneath your feet. From the anode to the cathode, through the electrolyte, these tiny lithium ions are working tirelessly, powering your journey towards a greener future. That's how the magic happens inside these batteries. Ever wondered what happens when you charge or drive your electric car? Well, let's delve into the fascinating world of charging and discharging. When you plug your electric car into a power outlet to charge, electricity from the grid flows into the battery. This electricity is converted into chemical energy, which is stored in the battery for later use. This entire process is what we refer to as charging, but what's fascinating is the role of lithium ions during this process. In a charged battery, lithium ions are stored in the anode, a component of the battery. When you plug in your car, these lithium ions move through an electrolyte, another component of the battery, and end up at the cathode. This movement of ions creates a chemical reaction, converting electrical energy into chemical energy. Now, let's talk about discharging, the process that powers your car when you drive. When you start your car, the stored chemical energy in the battery needs to be converted back into electrical energy. This is done through the reverse movement of lithium ions. The ions move from the cathode, through the electrolyte, and back to the anode. This reverse movement triggers a chemical reaction that converts the stored chemical energy back into electrical energy. This energy is then used to power the electric motor, which propels your car forward. So in essence, charging and discharging are all about the dance of lithium ions from the anode to the cathode and back again. It's this dance that converts electricity into chemical energy and vice versa. And it's this dance that's happening every time you plug in your car to charge and every time you hit the accelerator to drive. It's a complex process, but at its heart, it's a simple dance of ions back and forth, creating and using energy over and over again. Charging and discharging, a cycle that keeps your electric car moving. Let's recap the journey of understanding electric car batteries. We started with a broad overview, diving into what these unique power sources are and how they've become an integral part of our transition towards sustainable transportation. We highlighted that unlike conventional cars, electric vehicles rely on these batteries, not just for starting and lights, but for the entire propulsion of the vehicle. Then, we dissected the components of these batteries. We saw that they're not just single entities but complex systems composed of several smaller cells. Each cell, with its anode, cathode, and electrolyte, plays a pivotal role in storing and releasing energy. It's like a big family, where each member has a specific job to ensure the smooth running of the entire household. As we move forward, we delved into the working of these batteries. We learned how during the charging process, lithium ions move from the positive cathode to the negative anode through the electrolyte. This movement is reversed during discharge when the car is being driven, creating an electric current that powers the vehicle. It's a fascinating dance of ions, happening right beneath the hood of every electric car. And lastly, we explored the charging and discharging process in more detail. We understood that while charging, energy is stored in the battery as potential energy, and during discharge, this energy is converted into kinetic energy to drive the car. This cycle of charging and discharging is repeated over and over again, powering our journeys and making electric vehicles a viable alternative to their gas-guzzling counterparts. So there you have it, a brief but comprehensive look at the marvel of engineering that is the electric car battery. From the individual components to the chemical reactions, every aspect plays a crucial role in making electric vehicles efficient, sustainable, and the future of transportation. Next time you see an electric car, you'll know the science that powers it.